Good afternoon, friends. My name is Manish Kumar. I am working as a lecturer at Government Women's Polytechnic, Girls, Patiala. And my today's topic is modern building materials and technologies. So let's start. Before starting to discuss about modern building materials, let's go back to the early human settlements and recall what they used to use for their shelters, structures. We all know we all know they used to live in caves. They used to use bamboos, thatch for their huts. They used to live on trees, and they were using stones also for their shelters. Now think a little and we can conclude that in those times some of the following factors limited or restricted the use of that kind of materials. First, need. They were not in demand of high strength or long lasting structures. They used to move on, so they erected temporary structures. Second, knowledge. Their knowledge was limited and they were not able to construct huge buildings accordingly. And availability of material was also one of the constraints, so they used locally available materials, which was again trees, thatch, stones, etc. And technology available with them was of very few advancements. And with the passage of times, our needs changed, our knowledge expanded, gradual invention and discoveries resulted in development of new materials and development of new technologies. All this resulted in different type of architecture, and we progressed from caves to the ultra modern skyscrapers, which goes almost 100 meters upwards in the sky. And now we are thinking of planning to build on the moon and on the Mars also. So in today's lecture, we will learn about some of the modern building materials and some of the new techniques and technologies which are being used to construct ultra modern structures, buildings, skyscrapers, etc. First, we will discuss what are the requirements of modern buildings. Modern buildings should be functionally okay, flexible, aesthetically pleasing, strong and durable, waterproof and safe, fireproof and fire resistant, earthquake resistant, economical, environment friendly, energy efficient, and if possible terrorist proof also. First, we will start with the functional aspects. Functions or functionality is not a problem these days, because no matter how big or small our functional requirement is, we have advanced and accurate technologies which can be used successfully or applied to achieve required goals in a building. For example, say we want to play a football indoors, we can build a complete structure which is column free and big enough to accommodate full football ground. And not only that, its roof can be made to open or close with the touch of a button. And to achieve this, we will be using some of the following modern building materials. First, high strength steel for some trusses. Second, high strength steel wires or strands. Third, reinforced cement concrete for columns and some anchorage blocks, etc. Here, look at the picture. This is a view of a stadium which is a covered one, and its roof is supported by huge and massive steel columns and cables. This is the external view. This is a slide of the same stadium, and it's a night view, and we can see that roof supporting structures columns go high in the sky. These dots indicate the roof supporting structure, top end of the roof supporting structures. This slide gives closer view of the supporting column, steel columns, and these are cables which are supporting the roof. This is also another slide showing a covered stadium. We can see that the roof is covered, and this arch and these are two huge arches which are supporting roof structure. This slide shows the internal view of the covered stadium. We can see clearly this is a playing field. These are seats for spectators on both sides of the ground, and we can see huge steel trusses used to support roof, and in the center we can see smaller lightweight trusses, and a transparent covering material over the roof. As we all know, second aspect is aesthetical. As we all know, aesthetics deals with looks of our buildings, and initially form of the building plays very important role in this. After form, finishing materials plays very important part, and we all know that form of the building is no longer a constraint. Almost any type of form is possible. This is very good example of a form oriented building. We can see a lotus type structure. It is a very famous lotus temple at Delhi. This is another slide showing form oriented buildings. This is another form oriented building showing abstract form. This is simply possible using lightweight steel and sheet metals and some glass. Again, all these forms are possible using steel, lightweight concrete, RCC, aluminium, Teflon coated fabrics, plastics, and high strength glass. Second part of the aesthetical was finishing materials. Finishing materials comes in variety of colors, paints, varnishes, textures, wallpapers, laminates, tiles, glass, fiberglass, composite boards, cladding stones, cladding metals, etc. And lot of permutation and combination of these materials can be applied to achieve the desired aesthetics. The next important aspect, that is strength and durability. Strength and durability is must for every type of a structure, and advanced research and development has made it possible to make high strength cement concrete, which is primary building material, along with high strength steel. Carbon fiber reinforced structural members are also stronger and lightweight. We all know that glass is brittle material and it breaks easily, but advanced research in this field has made it possible to manufacture glass which is strong enough even to resist bullets. Apart from all these, admixtures are added to concrete to increase its strengths. Polymers are added to mortars to enhance its binding properties. Pre-stressed concrete is also a very good example of high strength concrete, and there are two type methods to do this. This slide shows a hydraulic jack used to pre-stress steels in pre-stressing. First method of pre-stressing is pre-tensioning. It is a very simple method. In this method, steel is stressed before concrete is poured and allowed to set, keeping steel in good tension. Concrete prepared by this method has much more strength and durability than ordinary reinforcement concrete. Second method of pre-stressing is post-tensioning. In this method, steel is stressed after the concrete is poured and allowed to set, then steel is tensioned. Concrete prepared by this method is also much more stronger than ordinary reinforcement concrete. Now let's understand the principle of pre-stressing by this slide. Here we can see in sketch 1, this is an ordinary reinforced concrete slab, and after heavy loading it will result into this shape. We can see a sag here. This is ordinary reinforcement concrete subjected to some loading. Now at the bottom we have a pre-stressed reinforcement concrete. In this first sketch we are showing a pre-stressed concrete, and after excessive loading it will result into this. We can see it is a horizontal and much more stable than this sketch. So we can conclude that pre-stressing of concretes makes it to bear heavy loads. This slide shows the stack of pre-stressed concrete blocks. These are blocks later used for some buildings or bridges. These are pre-stressed blocks. This is an anchoring member used for post-tensioning of concrete, post-tensioning of steel in pre-stressed concrete. We can see here these are high tension steel wires or strands This is plug. This slide shows the pre-stressing of steels. We can see lot of plugs, wire strands. Next aspect of modern important building is weatherproofing and safety. Weatherproofing and safety of structure is also one of the most important aspect of modern buildings structures. Following factors should be kept in mind. First, environmental like rain, snow, dust, etc. Second, thermal stresses due to heat and cold, etc. Third, chemical effects due to pollutions, etc. Fourth, biological growth due to poor cleaning and maintenance, etc. And to counter all these above listed factors, we have advanced materials which can be applied and used to counter all those threats. First, anti-corrosive coatings. We can protect our structures by applying some anti-corrosive coatings. Second, adhesives and bondings. We can properly bond different structural members so that there is no leak. And if there is a leak, we have high strength repair mortars and curing compounds. We have joint sealants, we have grouts, we have waterproofing systems for roof, and some special materials, other special materials also. And various compounds used for these are a different type of epoxies, polyesters, acrylics, polysulfides, polyurethanes, and silicons, etc. Thermal stresses due to heat and cold can be countered by good expansion and contraction joints. This is very important. Our buildings expands in hot summers and contract in winters. So we must provide expansion joints in all our buildings and properly water seal them so that there is no leakage. For that we need joint sealants, grout, and there are other methods of waterproofing of joints also. Weathering and safety, expansion joints. These are provided in buildings at some regular distances. This is a sketch showing these are two part of the slab. This is one part of the slab, this is one part of the slab. This is the expansion gap provided between the slabs. We can see that at the top a brass or bronze cover plate is provided, and we can see that inside there is also copper water stop. This is also this type of metal plate, and we can see that at the bottom also brass or bronze cover plate is provided. This is a very good example of expansion joint. This protects buildings and stops the cracks, stops the forming of cracks. Here's another example of a joint. In this joint also, at the top a brass or bronze cover plate is provided, and continuous copper water stop is also provided here also. This is also a very good expansion joint. Next aspect is fireproofing or fire resisting. No building can be made 100% fireproof, so there is always hazard of a fire. So our main aim is to make buildings as fireproof as possible. Second, detect any symptoms of fire as early as possible. Third, quickly contain that symptom and stop it from further escalating. Next, in case of a fire, quickly contain it. Next, quickly inform users and firefighting authorities. And last, quick and smooth evacuation of peoples occupying the building. It is duty of all the architects and planners to deal and work on all these parameters and make buildings as safe as possible, and we have tools and technology to do all these things. First, we have fire retardant materials, finishes which can be incorporated in modern building complexes. We have fire resisting paints, we have fire retardant materials, fire retardant concrete, fire retardant mortars. We can use all those materials. Second, we have different type of detectors like heat detectors which makes a siren when there is a certain rise in temperature. Then we have smoke detectors which detect smallest of smoke and again give sirens when there is a smoke. Then there are fire alarms which goes automatically when there is a when there is a fire. Then there are fire detectors also which detects fire and make alarm. And to quickly contain that fire, we have automatic sprinkler systems which gets activated in case of a fire. This is very good system. It detects fires and automatically starts sprinklers which very soon finishes the fire. We have a network of fire hydrants within building complex strategically located so that these can be put to use in case of a fire emergency. We have a wet pipe system which have continuous water at high pressures, and this water at high pressure can be used to dose the fire whenever there is a need. Next, fire alarms are networked with fire departments and paramedical services which can come into action without wasting precious times. These alarms quickly automatically inform fire departments and paramedical services so that they can swing into action and save precious lives. For quick and smooth evacuation, fire exits are prominently displayed in the buildings, and special fire escape staircases and fire escape lifts are provided which can be used in fires or some emergencies. Mock fire drills are also exercised. Pupils are educated, informed about the fire hazards and what to do in case of a fire. And some buildings have helipads which are incorporated in terrace designs to help evacuate stranded people from rooftop also. In India also we have many multi-story buildings with helipads for this purpose. This is a 7-star hotel at Dubai. We can see in the picture here it is a helipad which can be used in emergencies or otherwise also. Next aspect is flexibility. Modern buildings are far more flexible than old conventional buildings. Yes, it is true. Column and beam designs has made it possible to freely distribute various functions in a building. Development of modular design concepts has also given us more freedom and flexibility. We all know that in grid structure, column and beam structure, we can plan our walls freely and distribute different functions as per our needs because of the freedom given by the beam and column structures. This slide shows huge column free space which gives layout flexibility. We can see this huge column free space. It can be used as per our needs. This is another slide shows flexibility of form. We can see this is very flexible form, abstract flexible form. It is very easily possible. Next important aspect is earthquake resistant designs. As we are going higher and higher, accommodating more and more persons in a given space, so it becomes our prime duty to save buildings from earthquake forces. And thank God we have advanced modern materials and techniques which are good enough to resist these type of forces. Earthquake resistant designs. We have high strength steels, we have high strength concrete, we have pile foundations, we have isolated footing design techniques, we have mass tuned dampers, we have hydraulic shock absorbers. All these helps in protecting the building during earthquakes. This is very famous building, Taipei 101. It has used mass-tuned dynamic dampers to counter movement of building during earthquakes. This is very tall building, we can see. Uh, this slide shows, here it clearly shows mass-tuned dynamic damper. This is very heavy, huge metal ball which is near the top end of the building, and during earthquakes it protects building from swaying. Here in this slide we can see that mass tuned dynamic damper, closer view of the mass tuned dynamic dampers. Here we can see the hydraulic jacks supporting it, and these are huge wire strands which are supporting this heavy metal ball. This is suspended in the air, and during earthquakes it counterbalances the movement of the building. Second sketch showing isolated footing designs. Here are two examples. In first example, this is ordinary foundation and this is a supporting structure. In this case we have a 1 and 2 isolation members. Here we have isolated our building from the foundations using some sort of separators. And this slide clearly shows what will happen in earthquake. Say there is a movement of earth in this direction, so our building will go into this direction. We can clearly see in ordinary foundation design. And here where we have used base isolators, we can clearly see that our building is straight and shock is absorbed by these isolators. This is closer view of the base isolators. These are lead plugging, these are rubbers, these are supporting plates 1 and 2. This is a detailed sketch of base isolators. This is another example of base isolation system. It separates superstructure and substructures. Here we can see this is a concrete substructure, this is a steel superstructure, and it is separated by these springs. And during earthquake, our building will, these springs will balance the movement, balance the earthquake forces and absorb the earthquake shocks. This is another sketch showing separation of columns from its base. Here it is very good example. We can see this is a part of the foundation and footing of a column. This member here supports the base of the column, and this is a round metal ball, and during earthquake this lower part of the ground can move right or left, and column will remain stable, building will remain straight, and there will be a slight movement horizontal and vertical in this ball. This is another sketch showing a bracing damper. We can see this is a bracing member, this is detail. Here also it is a hydraulic damper which also absorbs shocks during earthquakes. So this is all about earthquakes. We have different more techniques also that will be covered in later chapters. Next is designing economically. This is also very important aspect. Though we have achieved much economy by mass production and modular designs, still we are far behind of providing comfortable and economical housing to huge number of peoples. According to me, this is a field in which a lot has to be done, and we are lagging far behind. Basically, we are not able to solve this problem and still we have thousands of people who are homeless. So this needs to be looked carefully. Next aspect is environment friendly and energy efficient designs. We can make our buildings environment friendly and energy efficient if we work and plan throughout our project, that is right from its site selection to the finishing of the project. Okay, we can for this we can start from the topography. We should respect the topography of the site as far as possible, and we should not disturb natural surroundings as far as possible. Designs are worked out to save material, space and energy. Design should be worked out to save materials, space and energy. Local available materials should be put to use. Natural lighting and ventilation to the building should be provided. In hot climate, double glazed reflected glass is used to reflect heat of the sun and allow light to come in. Yes. Next, and heat energy of the sun is used to generate electricity using photovoltaic cells. We can generate lot of electricity by this method. And in cold climates, heat of the sun is trapped and light is also allowed to come in using fixed glazing facades. This is very good example of a fixed glazing facade. This will allow building to heat. This will trap heat of the sun. This is very good design for cold climate countries. Next, some buildings are fitted with wind turbines to generate wind electricity. Recently, Taiwan and Bahrain have developed this technique and they are working on this technique. And there are some buildings which incorporated wind turbines into the design of the buildings. Next is rainwater harvesting to incorporate building designs. We can collect all the rainwater and use it to recharge the groundwater, or simply use the water for some landscaping purposes. Next, waste is to be separated, treated and then suitably disposed. This will also help to save environment. Next, terraces can be landscaped to reduce carbon footprints. And even walls can be covered with green landscape, which many architects are doing. Innovatives and lightweight materials can be used for buildings. Recycled materials can also be used to cut costs. Here are some slides showing modern buildings. This is another form oriented building, modern building. This is another view of a modern building. This is another view. Again, this is a slide showing a building with using modern building materials. This is another slide showing steel and glass structure. This is structure in lightweight concrete. This is also a structure in lightweight reinforced concrete. This is also a modern building with modern building materials. We can see lot of steel, glass. This is another example. Hereby we can conclude that modern materials and technologies have an upper edge over the old conventional materials that had been in use for decades or maybe centuries. Before finishing, let's recall what we have learnt. What are the modern materials?